get started here. Okay, so we're over here. Again, add on 4.9. Obviously, I missed it. So we're supposed to do 4.9. That was over here, but I didn't put it on the other side. Okay, but we're doing fine. So I should be able to start some at 4.8 today. Okay, so we'll see how it goes. All right, and a reminder, 4.7, skip problems 27 and 29. Okay, so I'll do some more problems from 4.7, then get started with some of 4.8. Okay. So there were some problems at the end that I didn't do. So let me just tackle some of those and then we're pretty much done. So I got done with identities. Okay, so an identity, I'm on page 250. Identity means show that the left side is always equal to the right side by using trig, algebra, and so forth. These two are always equal. Now, these are equations, which means they're not always true. You're trying to find the x values which make it true. So the left side and the right side are not going to always be the same. They'll be the same for what values of x. That's what they're trying to say. Okay, so I'll show you a couple of those, and then I'll be finished with 4.7. Okay. Okay, so problem 39, show you that one. Sine of 2x equals sine of x between 0 and 2 pi. Okay, so how do you do something like that? All right, the best way to do this is not to have a double angle. You don't want to have a double angle mixed up with a regular angle. So I'll use identity for sine of 2x. So one of the formulas for sine of 2x is 2 sine x cosine x. Okay, once again, put that on your cheat sheet if you want. Sine of twice an angle. See if I can verify where that is in the book for you. Yeah. Sine of 2x, 2 sine x cosine x. It's on page 244. I also gave it to you earlier. And here's a formula for cosine of twice an angle. Okay. All right, so 2 sine x cosine x equals sine x. Move the sine x over. That's what that arrow means. Subtract it over. That way you get a 0 there. You want to use the 0 factor property. So 2 sine x cosine x minus sine of x is equal to 0. Factor out the sine of x. You have 2 cosine x minus 1 equals 0. Okay, so when you have it like that, you have something times something equals 0. That means either this one is 0 or this one is 0, right? If a times b equals 0, either a is 0 or b is 0. So sine of x equals 0, or 2 cosine x minus 1 is equal to 0. A little bit of algebra shows you that this says cosine of x is 1/2. Add 1, divide by 2. All right, so sine x equals 0. Okay, the y coordinate is 0. That's here and here. Okay, so what angles will that be between 0 and 2 pi? Well, you have 0, pi, and 2 pi. 0, pi, and 2 pi. Cosine of the angle is 1/2. Okay, so x coordinate is 1/2. So I go halfway across here, and there's an angle there. There's an angle there. So that looks like it's 60 degrees or pi over 3. And this one over here is 360 minus 60, 300 degrees, which is 5 pi over 3. Okay, so I have 0, pi, 2 pi, pi over 3, and 5 pi over 3 are my solutions. Okay. Right, then the last one I was going to show you is 41, and then that's pretty much about it. So 41, 2 sine squared x plus cosine x minus 1 equals 0. Again, when they write it like this, sine of x squared, it's sine squared of x. All right, I want to get this in terms of just one trig function. I don't want to have sine mixed up with cosine. So I can change sine squared to 1 minus cosine squared. Okay, that's always a possibility. Okay, so let me rehash something here. So a little timeout. We know sine squared theta plus cosine squared theta equals 1. Okay, so if I subtract cosine squared theta on both sides, I always have sine squared theta is equal to 1 minus cosine squared theta, if I need it. Right? Subtract cosine squared on both sides, it looks like this. Okay, and similar fashion, you can always say cosine squared theta is equal to 1 minus sine squared theta for the same reason. If I subtract sine squared of theta on both sides, then the equation looks like this. Okay, so sine squared equals 1 minus cosine squared equals 1 minus sine squared of theta. So I'm employing that over here. 2 sine squared x, 2 times 1 minus cosine squared x. And by the way, you say, what do you want to do that for? That way I just have one trig function. I prefer to have only one trig function. Yes, over here you might say, well, there wasn't only one trig function, there were 2 trig functions. Yes, but after factoring, when I got it in factored form, this had only one trig function, this had only one trig function. Okay, when I had to set that equal to 0. Okay, when I have to set this whole expression equal to 0, I just want one trig function. Okay, so distribute 2 minus 2 cosine squared x plus cosine x minus 1 equals 0. Let's see, 2 minus 1 is 1. So negative 2 cosine squared x plus cosine x plus 1 equals 0. This is a quadratic equation in cosine x. I usually don't like to have that leading coefficient be negative. So to make it positive, just multiply both sides by negative 1. Okay, all that does is change each of these signs, and 0 times anything stays 0. So positive 2, negative 1, negative 1. Okay, so 2 cosine squared x minus cosine x minus 1 equals 0. Okay, so I factor this. Okay, if you pretend cosine x is like the variable, right? This is just like 2a squared minus a minus 1, right? Where a is the variable. Just pretend cosine x is the variable. So 2 cosine x, 1 and 1, plus and minus. And of course, you can double check by foiling it back out. Let's try it. First, 2 cosine squared x, there it is. Outer, this times this, negative 2 cosine x. Inner is plus 1 cosine x, that's a negative cosine x. And then the last minus 1. Okay, so then I use the 0 factor property again. Either this is 0 or this is 0. 2 cosine x plus 1 equals 0, or cosine x minus 1 equals 0. Right, so from algebra, if a times b equals 0, then either a equals 0 or b equals 0. Okay, a little bit of algebra here. Cosine x is negative a half, and cosine x equals 1. All right, so where's the cosine equal to 1? That means on my unit circle, the x coordinate is 1. It's only here. So that's 0 and 2 pi. 0 and 2 pi. Cosine of x is negative, that's a half there. Negative a half. So I go to an x coordinate of negative a half. I go halfway across. Doesn't have to be that accurate. And there are 2 angles, one here and one here. So I just have to decide what are these angles. Okay, so again, that looks like 30 degrees. That would make this whole thing 120, which is 2 pi over 3. Okay, you can use the conversion formula, either pi over 180 or 180 over pi as necessary. Or another strategy is, this is 120 degrees. I know if I go all the way around a circle, that's 360 degrees. So this is 1/3 of a circle, right? 1/3, 2/3, full circle. So 1/3 of 2 pi is 2 pi over 3. If I go another third, 4 pi over 3. If I go another third, 6 pi over 3, 2 pi. All right, so putting the angles in order, 0, 2 pi over 3, 4 pi over 3, and 2 pi. I guess you could say every third of a circle, you've got the point. And you're going from 0 to 2 pi. Okay, and that's about it, folks. So I'm done with 4.7, and I'm ready to start some of 4.8. So originally I wasn't supposed to get started until Monday, I guess, but we're fine. So start sum of 4.8 now. And we're doing the inverse trig functions now. So inverse trig functions. Okay, first a brief review of some properties of inverse functions in general. Right. So if a function is 1-to-1, you might recall, That means 1x gives you 1y, 1y gives you only 1x. A one-to-one function passes both the vertical and horizontal line tests, you might recall. Okay, so the inverse function is unique. The domain of one becomes the range of the other. That's what both of these essentially say. Okay, because you're switching around x and y. For the inverse function, you switch around x and y. So if you swap x and y, the domain and range switch. Okay, and here's a property about the switching. Okay, f inverse of x equals y means the same thing as f of y equals x. Okay, so for f inverse and f, you just switch around the x and y. Okay, so f inverse of x equals y means f of y equals x. Okay, and since they're inverse functions of each other, anytime you do one followed by the other, f of f inverse of x, you get back the original x. Or you could switch it around and say f inverse of f of x is also equal to x. Okay, so those are some properties of inverse functions. The graph of an inverse is a reflection of the graph of y equals f of x about the line y equals x. That's true. You don't really need it that much in this section. Okay, so these are properties of inverse trig functions. It's on page 251 in the text if you want to follow along with that. Okay, and as always, you're welcome to put any or all of these on your cheat sheet. I really don't think you need too many of these. Okay, you can maybe put this one down just to remind you, but you should know that's what inverse means. It's an undo function, right? It brings you back to where you were. Okay, so I'll give you my summary. Now the book has their own summary. There's nothing wrong with it. It's correct, but I'll give you my variation of it. On page 252, they talk about the arc sine or inverse sine. Okay. Then on 253, you have the arc cosine function. Everything here is correct. I'll give you again my version. Then on 255, the arc tangent. Okay, and we're not going to use the others that much. There are arc secant. I'm barely going to talk about it. Arc secant and arc cosecant and arc totangent. They're there, but we're not going to emphasize them that much. Okay, so here's my version, my take on the inverse trig functions. Okay, there's actually a couple of ways you can write it. Y equals arc sine x, or y equals, it looks like sine to the -1 of x, but we say inverse sine. Okay, these two mean the exact same thing. Okay, arc sine or inverse sine. Okay, side note, on many calculators to get the inverse sine, it's the upper register. We're not going to be using it that much right now, but the next section we will. So notice for most calculators, above the sine is, it looks like sine with a -1. Same for cosine, cosine -1, tangent, tangent -1. Okay, it's not an exponent. It's inverse sine, inverse cosine, inverse tangent. And to get the upper register, you have to hit this button. On my calculator, it's yellow, but I've seen blue, I've seen green. It's second function. It gives you the upper register keys. Okay, so these mean the same thing. Y equals arc sine x or y equals inverse sine of x, same thing. Please note, sine with a -1 there, x, does not mean reciprocal, like 1 over sine x. Okay, so it does not work the same way as if you had, let's say, y to the -1 power or something like that. Then you would go 1 over y. This does not mean reciprocal. We already have the reciprocals. The reciprocal of the sine is called cosecant, right? So it can't mean the same thing. So arc sine. Okay, so y equals arc sine x means sine of y equals x. Okay, they mean the exact same thing. Furthermore, though, okay, and you might want to put this on your cheat sheet because you actually might have a conflict here. Okay, so y equals arc sine x or inverse sine x, they mean the same thing. Sometimes people say sine inverse of x. It means sine of y equals x, but the angle, so you take the sine of an angle, right? The y has to be between and including -pi/2 and pi/2 by definition of the arc sine function. Okay, so the angle that you want in question is between -pi/2 and pi/2, or -90 degrees and 90 degrees, in order for it to be a function. Otherwise, you would see after a while this would not be a function. You could have infinitely many angles that make something true. but the only angle that you want, and you're only going to get one, if you pick something between negative pi over 2 and pi over 2. Okay, so you definitely might want to put this on your cheat sheet. For arc sine, okay, the y, the angle is between negative pi over 2 and pi over 2. Okay, how about arc cosine or inverse cosine? Again, they mean the same thing. Okay, this is short to the right, but this is easier to type. Like if you were to type on your keyboard, right? You can't really type that very easily because most keyboards, regular typing keyboard, you don't have that -1 floating up there. So if I were typing to you guys on the computer, say I would type arc cosine rather than this because I can't get that very easily. Okay, so arc cosine x, y equals arc cosine x means you say, I don't like the arc. I don't really like it either. So how do you write it without the arc or the -1? You just put cosine and switch them around. So you're not taking a cosine of x, you're taking a cosine of y equals x. Just switch it around. Okay, and this time the angle y has to be between 0 and pi by definition of the arc cosine function. Okay, again, it's in order to make it a function. It may not be evident now why we have that, but this is to prevent us from having multiple answers. We only want one answer. We want a function, essentially. Okay, and lastly, arctangent function, y equals arctan x, or inverse tangent of x. It means the same thing as tangent of y equals x. So whenever you have a chance to unscramble the arc or the -1, you should say, I'm not as comfortable with the -1. Yeah, I'm not either. So you want to get rid of it. And the way you get rid of it is, well, you're not taking the tangent of x. You're taking arctangent of x, right? So it doesn't make sense that arctan x is the same as tangent x. So I must be taking the tangent of something else. Right? Well, what else is there? The only other else is y. So I must be taking the tangent of y. So tangent of y is equal to x. Okay, and definition for arctangent, almost like the sine function, the angle y is between negative pi over 2 and pi over 2, but this time not including negative pi over 2 and pi over 2. So notice here there's a line underneath it. You're including the possibility of negative pi over 2 and pi over 2. There's no possibility here. You can see why not. There's a very good reason, because tangent of pi over 2 doesn't exist, and tangent of negative pi over 2 doesn't exist either. Okay, so it goes like that. All right, so I would say for sure, unless you want to memorize it, I'm guessing you probably don't want to memorize it, then put this for sine, arc sine of x. The angle has to be between negative pi over 2 and pi over 2. Arc cosine, the angle is between 0 and pi. Arc tangent, again, between negative pi over 2 and pi over 2. This one does not include the endpoints. This one does. Okay. So let me show you what we're up against. So 4.8. Okay, and we are on page 259. And again, I'll show this to you for those of you that don't have the book and don't plan on getting it. Okay, so there's some problems up to 19-ish. And there's some more. And some more. And how far do we have to go? Up to 45. Okay, so show you this side. And there we go. Okay, so how do you do problems like this? Right, the arc, cosine, and whatever. They don't give us too many like arc secant. Okay, so we'll touch on it, but there's a very easy way to tackle that kind of problem. Okay, and then how do you do all this other stuff? Okay. All right, number one, arc cosine of radical 3 over 2. Now, the original problem just says this. I highly suggest that you call it something like theta. Okay, so arc cosine radical 3 over 2 equals theta. Now, unscramble it, quote unquote, write it without the arc. Okay, so how do I write an equivalent equation with just cosine? I don't want the arc. So I'm taking the cosine of something. Well, could I be taking the cosine of radical 3 over 2? No, I'm taking the arc cosine of radical 3 over 2. It wouldn't make sense for a cosine of radical 3 over 2 to be the same as arc cosine of radical 3 over 2. So I must be taking the cosine of something else. What else is there? There's only one other choice, theta. Is that right? So cosine of theta is radical 3 over 2. Okay, now how do I do this? By analyzing unit circle. I'm not as comfortable with radical 3 over 2. I'm much more comfortable with sine of 1/2, sorry. Okay, if the cosine is radical 3 over 2, the sine is automatically a half. Okay, remember on your unit circle, radical 3 over 2 is always paired with a half, plus or minus. Okay, so I could go radical 3 over 2, which is 0.866. You can go 86.6% of the way. I'd rather not. Okay, I think of sine of theta is a half. So on my unit circle, I go half a unit up. That's 1/2 there. Okay, and I draw myself the angle. That looks like 30 degrees. So the answer is pi over 6. Okay, now you might argue there are more angles that make this true. And that's correct. There's an angle here in the fourth quadrant. I can go all the way around a circle and come here. I can go around twice and come here. I can go around 3 times and come here. So you actually have infinitely many angles that make this true. But for arc cosine, the angle must be between 0 and pi. Okay. With that restriction, there's only going to be one angle, pi over 6. Okay. So I'm not allowed to use the fourth quadrant angle. I'm not allowed to go all the way around once, twice, 3 times, as many times as I want to get that. You can only have one angle. See, otherwise, to solve just this, if you ask me, just solve that, there are infinitely many solutions. Okay, I got pi over 6, I got negative pi over 6, and I have multiples of 2 pi going all the way around and backwards. Okay. But if you tell me I can only pick an angle between 0 and pi for arc cosine, then there's only one angle, pi over 6. Okay. All right, number 3. Arc sine of 1 equals 0. Okay, again, the problem just says arc sine of 1. A lot of times the parentheses are optional. You don't have to put the parentheses. Here it would be nice to have the parentheses because there's a negative there. It just says arc sine of 1, but I am going to call it theta. Okay, now rewrite it without the arc. Just say sine. Am I taking the sine of 1? No. I'm taking the arc sine of 1. I must be taking the sine of something else. There's only one of the else, theta. So sine of theta equals 1. And that's the inverse property, right? You switch around the x and y. Sine of theta is 1. Y coordinate is 1. That's up here. Theta is pi over 2. So that's my answer, pi over 2. Now, again, you might say, well, if I go all the way around a circle and come back, there's another angle. Or I go around twice and come back, or go around 3 times, and I can go negative and get there and go around negative as many times as I want. But for arc sine, you can only have an angle between negative pi over 2 and pi over 2 inclusive because of the line underneath it. So if you're restricting me to only between negative pi over 2 and pi over 2, negative 90 and 90 degrees, there's only one angle, 90 degrees, or pi over 2. Okay. Okay, 7's a little bit harder. Arctan of radical 3. So I have to show you a little trick for that one. Arctan of radical 3. Okay, call it theta. Unscramble it. Tangent of not that, so it must be tangent of theta equals radical 3. Okay, so here's the trick. I've already shown it to you maybe, but too late. But okay, tangent is sine over cosine. Sine theta over cosine theta is radical 3, which is radical 3 over 1. Okay. The trick is now divide top and bottom by 2. Okay, so why? Because it works. Okay, that's the only way I can explain it. It's legitimate, you're allowed to do that. But if I divide top and bottom by 2, it works. Then I just read across, sine of theta is radical 3 over 2, and cosine of theta is a half. So both of these have to be true, right? Sine of theta is radical 3 over 2. Look at the top. Cosine theta is a half. They're both going to be true. Which would I rather work with? A half. I don't like radical 3 over 2. That's again about 0.866. All right, cosine theta, x coordinate is a half. So I draw my unit circle, right? I go halfway across. I know that's 0. I know that's 1. So there's 1/2. Okay, so I got a point over here and over here. Okay, but for arctan, let's see, coming out to be positive, it has to be quadrant 1, right? So I'm in quadrant 1. So that looks like 60 degrees, so pi over 3. So my answer is pi over 3. Notice for all these problems, I never really use my calculator. You should be able to analyze without a calculator for these. Now, of course, on the exam and quizzes and so on, you're allowed to use your calculator, but you should show me this kind of analysis, that you could do it without a calculator, and then only use your calculator as a double check. Okay. But for instance, if you go straight from here to here, you don't get any credit. Okay. Because that probably tells me you just punch it in the calculator. I need to see this analysis, just like I'm doing here. Okay. All right. Now, arcsecant. Here's our first instance of arcsecant, number 11. Arcsecant radical 2. It's really not that big a deal. I'll just take the reciprocal when I need it. Okay, so the original problem says arcsecant of radical 2. So I'll call it theta. Get rid of the arc. Secant of not radical 2, so it must be the other thing. Secant of theta equals radical 2. Okay. Then at this stage of the game, immediately change to the reciprocal. Reciprocal of secant is cosine. So I flip this, flip this. If two things are equal, their reciprocals are equal. So reciprocate here, cosine theta. Reciprocate radical 2, 1 over radical 2, or radical 2 over 2. Aha, that's something I recognize. Okay, so cosine of what nice angle is radical 2 over 2? Pi over 4. Okay, so my answer is pi over 4. Again, for arc cosine or arcsecant, well, it's positive, so you know you're in the first quadrant. Okay, so I only want stuff between 0 and pi. So that tells me you're not allowed to keep going around the circle or negative. Otherwise, you have infinitely many solutions. Okay. All right, so I'll do some of these harder ones now. Okay, find the exact value of each expression. So they're asking you for cosine, blah, blah, blah. Okay, so this part, if I kind of cover these up, these here are just like this. Right, so you come back with some angle. Okay, and then once I have that, I do the other function that they say. Right, so by order of operations, I'm supposed to do, what's inside first. Okay, I'll just mention quickly something like 15, cos of arc cos. They automatically cancel each other out, right? So the answer to 15 is automatically a half, cosine arc cosine. Okay, but what if they give me something harder like this? Okay, so let me show you 19, tangent of arc sine radical 3 over 2. Okay, so first I call it theta. See, if I just said arc sine radical 3 over 2, that looks like all these other problems, right? So I'll work out the problem first, just like it's this. Then when I get out, take the tangent of the angle. Okay, so I'm ultimately finding the tangent of theta if I'm calling this thing theta. Okay, so theta is arc sine radical 3 over 2. Okay, unscramble it, write it without the arc. Okay, sine of theta equals radical 3 over 2. Okay, you're not taking the sine of radical 3 over 2. You must be taking the sine of something else, theta. All right, I'm in the first quadrant because this is positive. Okay, I know radical 3 over 2 is always paired with a half. So sine of theta is radical 3 over 2. Cosine of theta is 1/2. And by the way, this is worth memorizing, but even if you got stalled and you forget all of that stuff, you can still go back to your formula, sine squared plus cosine squared equals 1, and come back to cosine theta is a half. Okay, so that would also work. All right, so tangent theta is ultimately what I'm looking for. Tangent theta is sine theta over cosine theta. So the sine is radical 3 over 2. Cosine theta is a half. And of course, I showed you that trick before. You can just cancel the 2's. So you have radical 3 over 1 or radical 3. And that's my answer. Okay, 21. Well, you have to be a little bit careful for 21. Arc, sine, sine. At first, you might say, oh, just cancel them out. Negative pi over 4. Not quite. Okay, it's actually going to work for this one, as we'll see, but you have to watch out a little bit. So let's just work it out anyway. So just go by protocol. Let me work it out. Arc sine of negative pi over 4. So let me just cover that up. Sine of negative pi over 4. So that's negative 45 degrees. That's negative radical 2 over 2. Okay, so this thing is negative radical 2 over 2. Okay, so now I'm taking the arc sine of negative radical 2 over 2. Yeah, temporarily call that theta. So sine of theta is negative radical 2 over 2. Okay, we trace our steps. And for inverse sine or arc sine, we need an angle between negative pi over 2 and pi over 2. Well, that does bring me back to negative pi over 4. Okay, so in this case, the answer is negative pi over 4. And so you say, oh, I can just cancel these out. That's true in this case, but you have to be careful. The next problem doesn't turn out to be that way, unfortunately. Okay, so don't go just carefree, just say, oh, cancel these out. The answer is negative pi over 4. No, you have to analyze it a little bit because that does not happen for the next one, 23. Arc cosine of cosine negative pi over 4. Okay. Right. So your first impression might be to say, oh, cancel out, these cancel out, negative pi over 4. Okay, well, not quite. Let's try it. So first, what's the cosine of negative pi over 4? So negative 45 degrees is right here. The ordered pair is radical 2 over 2, negative radical 2 over 2. So remember, right there, pi over 4. Right there, 3 pi over 4. Right there, 5 pi over 4. Right there, 7 pi over 4. Both x and y are plus or minus radical 2 over 2. Just figure out what quadrant we're in. Quadrant 4, x is positive, y is negative. Now, right here, cosine means give me the x coordinate. So the x coordinate is radical 2 over 2. Okay, so this thing right here is now radical 2 over 2. Okay, so I'm doing arc cosine of radical 2 over 2 is equal to theta. Okay, unscramble that. Cosine of theta is radical 2 over 2. Okay, now by definition of arc cosine returns an angle between 0 and pi. Okay, I'm not allowed to go back and use negative pi over 4. I can only pick pi over 4 now. Cosine of what nice angle between 0 and pi? This is a little bit tricky. Where'd it go? Here we are. Between 0 and pi. Okay. Cosine of what angle is radical 2 over 2? Only pi over 4. So you can see in this instance, it didn't work. It didn't work the same way. Okay, so in this case, the final answer is just pi over 4. Okay. Okay, folks, so that was all I was going to do today. So I'm just about done. I'll let you ask questions if you have any. If not, we'll be done. Let me just show you where we're headed next. Okay. Next, we have some other combinations going on, like what if you have a cosine and an arc sine or a cosine of a sum and all that. Then we have to use some other tricks that we've seen before, right? So I have to show you how those work in time. Okay, but otherwise, that's it for today. So let me stop the share and see if you have any questions. Check the chat. Okay, nothing in the chat. Okay, so Yeah, Maxwell, did you have a question? I can't hear you. You can unmute yourself or put it in the chat.
Yeah, I do have a question. How would you do on number 43 in 4.7?
4.7, which one again?
Number 43.
4.7, 43. 4.7, 43. Okay, we can look at that one. Okay, so let me write that down here. 4.7, 43. Tangent x plus cotangent x equals 2 over sine 2x. Find values between 0 and 2 pi. Okay. Okay, so let me go back to sharing the screen. Okay, let's change this to sines and cosines. So this would be sine x over cosine x plus cosine x over sine x. This is not an identity, so that means you can't cross over and so forth. 2 over, okay, sine of 2x by formula is 2 sine x cosine x. Oh, these cancel out. Okay, how about multiply both sides by sine x cosine x? Sine x cosine x. Distribute, distribute. So the right-hand side turns out to be just 1. If I multiply this by this, cosine cancels out, so I have sine squared x. Okay, if I multiply this by this, sine cancels out, I have cosine squared x. Well, this turns out to be always true, so this happens to be an identity. Okay, it's always true whenever it's defined. Okay, so let me double check real quickly for 43. It was find all values between 0 and 2 pi. Okay, so we know everything works except for whenever the denominator is 0. Okay, so the denominator is 0 whenever cosine or sine was 0. Now that's here, 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 here. Okay, so there's a couple ways you can write that. So my solutions are basically everything between 0 and 2 pi, except for these things. So one way you can do it is the open interval from 0 to 2 pi, and then throw out all of these. So minus pi over 2 pi, 3 pi over 2. Or you can write it in terms of a bunch of intervals. Okay, you can take that interval, union that interval, union that interval, union that interval. So that's more work in my opinion. So 0 pi over 2, whoops, union pi over 2 pi, union pi, 3 pi over 2, union 3 pi over 2, 3 pi over 2, 2 pi. So basically saying everything works except for a few numbers. Okay, because it turns out to be an identity in this particular case. Okay, that's a 2 there, sorry. 2. Okay, and let's see, anybody else please with something? No? Okay, that'll do it for today, folks. So we'll just pick up with this tomorrow. All right, so have a good day. We'll see you tomorrow. Thank you. Bye.
Meeting.